the like train model function in our app is running. There's 5 containers, so 5 GPUs, now 4. And now let me pull up the TensorBoard, the Swagger docs for our web endpoint, and the Gradio UI. In today's webinar, I want to show how you can build your own MLOps stack on top of Modal. And this is something that is near and dear to my heart because I've worked in MLOps now for about 5 years, worked in ML research before that, and felt the pains of operationalization of research ideas. So this is something that I've always wanted to make good, and that Modal helps me make good. So I'm going to do a quick presentation first, and then we'll dive into some code and a live demo. Let me show you why MLOps doesn't have to suck and why Modal helps solve that problem. So first, I actually think the right way to understand this is to ask, like, why do we have MLOps at all? It's not because we really like writing YAML files and that's our favorite thing in the entire world. It's to help solve like a very kind of like high level and very serious like organizational level problem for anybody who wants to use ML for product. So there's a bunch of different sort of like famous diagrams that express this idea, but the like key contribution of ML ops to an organization is speeding up this virtuous cycle, this data flywheel, this iterative loop of improvement, whatever you want to call it, that makes ML applications better. So this diagram that I have up here in the top left comes from Hamal Hussein's blog, Your LLM App Needs Evals. That was sort of expressing something that he had learned from trying to make LLMs work in production with a bunch of teams. And the key thing about this diagram is that it's a loop, not a pipeline. The goal is to like deploy models out to the world that like allow you to, in a way that allows you to like curate data for evaluating that model in the future. And this is like, this wasn't new with LLMs. This is something that was known with machine learning. Shreya Shankar has this figure in her paper on operationalizing machine learning. It's available on Archive. It's an interview study with ML engineers, and it has this, it's a like an incredible breakdown of like what problems people actually run into when they try and, you know, build ML ops, build ML systems and operationalize machine learning. And the like figure 1 in that paper is this like loop of improvement that involves experimentation very critically based off of data that you get from production, based off of new modeling ideas, whatever. That experimentation is in a loop with like deployment and monitoring. And, you know, we've got this big circular loop here. So the like key idea I'm trying to get across here is that ML ops is what is like all of the tooling, infrastructure, and also the sort of like organizational practices and ideas that like make up this loop, and that make this loop run faster. The faster you can run this loop, the larger scale data you can collect, the more quickly you can learn things about your model application, and the better your model will become. And in fact, like even more deeply, I would say that it's like this loop is actually the thing that you are building. Models are not really the thing that you are building in an ML team. And like it's actually even the like product isn't really the thing that you are building directly in an ML team. Like maybe like often actually there's somebody else who's kind of working on the product layer. The thing that you're building is this system that like can produce new and improved models over time on the basis of production data. So Andre Karpathy and Josh Tobin and others have like made this point repeatedly. It's like the data engine or the data flywheel is the like, you know, the real value. It's the real end goal. And like, if you think really broadly about this, I'll kind of speed through this, but if you think really broadly about this, this is also like, it's the goal of DevOps. Like, let's get our code out there in the world, find out what's wrong with it and fix it, find out how people want to use it and like extend. It's like DevOps is actually about this loop and going from this like throw software out in shrink wrap CDs and into like a loop of like continually releasing and improving and deploying your software and your application. And this like goes all the way back to the way people think about building startups with like the lean startup movement and building businesses in general, and all the way back to things like the like Toyota production system and the sort of like way that we think about building any sort of like complex, non-deterministic, like in contact with the real world kind of system, like a business, a complex software application, or a machine learning model. So it's like this is really deep. Like this is the like it's a very important way that you like as somebody who works in machine learning can deliver value to your organization. Even it might seem boring or humdrum of like operationalizing and building these platforms, but it truly is like this very like it's a organizational superpower to get this right. The bad news is that I think like as a field, MLOps is like not really fully delivered on this vision. It's like pretty hard to set up something like this. Like an automated version of this was always the dream, like Andre Karpathy's Operation Vacation, where you set up like a continually learning ML system, and then you just like it gets better and you don't have to do any work. That's like not really come off, with maybe one or two exceptions, like Google's ad click-through rate system that they described in their paper From the Factory Floor. Rohan Anil, the first author on that. Like a few teams have been able to achieve this, but most people have not been able to. And there's a number of reasons why. Like data limitations are an important one. In the era of foundation models, maybe some of those data limitations are reduced by synthetic data. Infrastructure limitations are another one. It's just like hard to set up all of that stuff. So there's tooling for this, but it's like difficult to like bring it all together and make it work. That question ideas, by the way, is something I've expressed in a couple of different places. If you want to like dive deeper on those, gave a talk on that with a couple of other people in the field, Shreya, Hamel, Eugene, Jason, and Brian at the AI Engineer World's Fair. That talk is sort of a summary of this article we wrote about like building with LLMs. That has some sections on operationalization and on the connections between like what ops looks like for LLM ops, AI ops, agent ops. What does that look like? How is it similar to and different from ML ops? Hot takes from the trenches available there. That's kind of the high level picture of like what is MLOps for, like what can it do. And so why would Modal, this like serverless infrastructure platform that helps you get H100s really fast, like, why is Modal important for MLOps? And I think the answer is that Modal is designed for really fast iteration speed. And iteration speed is the name of the game with these like loops of continual improvement. And iteration speed has been one of the like critical problems with many like MLOps tools. So Modal makes like experimentation lightning fast. We like rebuilt the container stack from the ground up, like compatible with the like Docker tools that you know and love, but not using their specific software implementations because they're just too slow and they lead to like slow loops for experimentation. And like, why do you need, why do you need containers in this case? Why do you need containers in ML? Why do you need them? Why do you need like cloud infrastructure here? It's in part because your experimentation, results in a lot of ephemeral environments, uses a lot of like maybe bleeding edge software. And so you want to like containerize things. And then it also requires like very heterogeneous and complex infrastructure. It can't just run on like any old EC2 instance. It needs a fancy EC2 instance like a G5 or a P6 or whatever, something that has like some beefy GPUs. And then also when you're experimenting, like at one moment you're like, okay, I'm like still messing around. I like haven't gotten this thing working. Like I'm like debugging the fact that PyTorch 2.5 breaks the attention in like Hugging Face transformers because of a cuDNN issue. True story. I'm like debugging that, and at one moment I only need like one GPU while I'm like figuring that out, or maybe no GPUs. And then the next I'm like, okay, cool. Well, I've got my model running, but I don't know how to set this hyperparameter, like the atom, like epsilon, and I don't know how to set this hyperparameter for the for the dropout or the like, or my data mixing, whatever these hyperparameters are. Now I need 100 GPUs because I just need to try 100 different values of this parameter. And so there's these like crazy changes in what infrastructure you need. And so the cloud is like really the only way to make that economical. And Modal is, in my opinion, the only system that makes that not only economical, but also like delightful, pleasant, easy, and like gets out of your way while you're doing this. From the perspective of your like VP of engineering, your team will be able to like get to insights faster without spending like a ton more money to just keep a bunch of GPUs hot that they're not using just in case they need to run an experiment. You don't have to like get a whole Kubernetes team to set up that like auto scaling infrastructure. You don't need like Pulumi experts and specific Pulumi experts just for the needs of your ML team. From the perspective of somebody who's an actual like ML researcher or a data scientist, it's like you get all of the power of having that auto scaling infrastructure without having to become AWS certified and having to learn a bunch of cursed things about how these cloud interfaces work. I think there are some like all-in-one tooling systems that claim to solve these problems for you. There's things like AWS SageMaker. There's equivalents on GCP like Vertex and on Azure. But my experience with these things is that you have to wait like 30 minutes for your code to spin up because it's like you're copying a bunch of Docker images all over the place, and people have not done the deep work that the Modal team has done to like, to speed that stuff up, to like have smart prefetching, smart lazy loading. And like the killer part about that, at least especially for me and maybe other people who are used to like an interactive Jupyter notebook type environment, that long iteration cycle means that anytime you make even like a simple mistake, like you forget a comma, you misspell something, and the thing breaks, like now it's 30 minutes to find out that you have that problem. So Modal, like it should be seconds. You should find this out like basically instantly. The other thing that's nice about Modal, I talked about this in a previous webinar, you can find that on our YouTube channel, is it makes it really easy to debug stuff. Like you can just like shell into like a new replica of your system to like see what does it look like when my thing starts up, when my application, my training run, whatever starts up. And like, or you can like just directly jump into something that's already running. You can interactively set breakpoints. You can get a shell, like an IPython REPL inside of a running code, and all those things are like fast and performant and clean. And that's something that many of these other tools like don't offer, or are, they're just like slow and unpleasant. And this is really critical with experimentation. Like this is nice for everything. All code has bugs. All code needs good debugging. But experimentation is like very iterative, interactive, and yeah, there's like no replacement for interactive debugging and like poking the system in these cases. For things in general, it's like you maybe are like building up your mental model of how Modal's infrastructure works. It's a distributed system. Like we make it as easy to use as possible, but there's only so easy you can make it. And there's things like where are files located, and like differences between local and remote environments, where like there's the best way to figure that out is just land in the remote environment and fiddle with it. And a lot of alternative ways of doing cloud development don't give you that. Like in a local environment, you always have that. You can always do it. But cloud environments, you have to work to provide that, and Modal's done that work. Finally, and like most importantly for what I'm going to show you in this webinar, Modal has all the primitives to build whatever custom tooling you need. You might say like, oh yeah, I need 100 GPUs. That's a good point. Well, maybe I'll go to some like serverless, like pure serverless GPU provider. Somebody who promises like, here, we'll hand you some GPUs. We'll like run your fine tuning for you. We'll like train models for you. Like that, I'll solve my problems that way. And that's good. But now like, okay, what if you want to like map, collect storage from that and like use that somewhere else in your system? Well, how good are their distributed storage primitives? Maybe you want to run a web server to do something like poke a model while it's training. Like how's the model training coming? Let me try this. Somebody just reported this weird edge case from production. Let me like just go in and try with one of the models that's currently training. Let me like send in some of this data from production and see if it still has the same problem. And so now you want like a web server, like a web endpoint or a UI on top of your models. And it's like, can you build that inside of that system? Or do you have to go and build something new yourself in some other system that you now need to integrate? Modal's got all of this stuff in one place. It's like, it's piecemeal. You don't have to use it if you don't want to use it. But it's like, it's all these primitives together in a single platform so that you can like build the like custom MLOps stack that you need out of like existing components. So to demonstrate that, I've built this like, honestly, it's a little bit janky. Like we're still figuring out how to make this work like super clean, like super nice. But I'm so excited about it that I just really wanted to be able to share it with people. It's a proof of concept of basically like a full stack MLOps system built on Modal. So let's take a look at that. You can find the code for this example on our documentation site, modal.com/docs/examples/HP_sweep_GPT. So this page, this is like a nicely rendered version of all of the code, the like main code script for this example. And what we're going to do is we're going to do the classic like Andrej Karpathy thing. We're going to train a GPT-2 style model on a Shakespeare data set. In the end, you don't get anything that would like win LMSys leaderboards or break any benchmarks. But it's just a demonstration of this path for training like your own small language model from scratch. And some of the fancy things that we're going to do is we're going to do a hyperparameter sweep. And for that hyperparameter sweep, we're going to like try out a bunch of different values, run them for a while, and then once we've had them running for a while, we'll like stop all of them, check what their validation scores are, and take whichever one is doing best and keep running that one. So that's a form of like early stopping grid search, or like adaptive compute in a hyperparameter sweep. That like because Modal is like auto scaling infrastructure, you just like you get those like 8 GPUs to train all at once, and then you switch down to just 1 GPU for future training. You could also like train on A10s for your like first for the initial part of your hyperparameter sweep, and then switch over to H100s for the end of it. Don't show that here, but very, very straightforward to build on top of this system. Some other things we'll monitor experiments with TensorBoard, so we can watch what is, we can watch the like models improve over time, check out their outputs, and then we'll also serve our model while we're training so that we can actually like play with it and see how it's doing, both as an API endpoint and as a user interface. So do I have a screenshot of that? Yeah. Looks better in dark mode, I promise, but that's the UI we'll serve. Okay, so let's see. Let me dive into the actual like code here. So you should now see my VS code. I'm gonna zoom in a bit, even though we won't be able to see as much horizontally, so that the text is legible. So I think maybe actually I'm just gonna, rather than doing the code, I'm just gonna launch a run here. So to like run training, it's modal run, that's like execute a script rather than like a deployment, which would be modal deploy. And that's going to trigger, that's going to both like trigger a training run, and it's also going to set up some like development servers for all of those other pieces of our MLOps pipeline, our endpoints and our experiment monitoring. So let me run that. So I did modal run. This like moved all of our stuff, like local code was put in the cloud. We like launched containers for things. That's all what's happening here. Like created a bunch of web endpoints. This is our UI, our training monitoring, and our endpoint. And then now we're doing 8 hyperparameter settings. Wanted to keep this like within Modal's free tier. And you can see we're spinning up a bunch of nodes. We got node 1 and node 2 have come up. They're starting experiments 3 and 4. Looks like we hit 5, 6, 7. Yeah, we get all 8 nodes launched, and now they're running training, and then a node is here like stopping, reporting its validation loss result. So I only train for a very short period here, just like to keep the example nice and snappy. But like, you could train for much longer, and you would probably train for much longer in a production setting. But yeah, so we're training here. They're all getting to the point where they're saving. Let me go up here back to my browser and show you the app dashboard. So this is our app that's that started. You can see the like train model function in our app is running. There's like 5 containers. So at this point, 5 GPUs, now 4. Let me zoom in maybe a little bit so that's more legible. So that's our like training component. And now let me pull up the TensorBoard, the Swagger docs for our web endpoint, and the Gradio UI. Jump back here. So I was just like hitting all of those. They weren't running actually. Like they were set up and ready to go on Modal, but they weren't running, which is really nice because it actually means like you don't have to pay for any of that infrastructure if you're not actually using it. So you can like create these endpoints, create these things that like might have access to an old experiment, for example, but then you don't have to like pay to keep that GPU warm all the time. So it makes this a lot more economical. So it looks like they're spinning up currently. So you can see the UI, web generation, and model inference are all spinning up here. Let's check in on our model training. So like I was showing you previously the model training in the command line. You can also view it here. Let's go to the full set of logs. All right, so we're back now. We're reloading a model. The model that did best. We're reloading that model and continuing its training. So that's what this this particular input, this particular function call is doing. Yeah, so one to like set up this big sweep of hyperparameters, and then another to like train the best one and follow on from that. All right, how is our app doing? Let's see. Oops. Let's go back there. Okay, so it looks like I think things were able to get started. So let's check on our TensorBoard. We got a lot of runs logged in this TensorBoard, so it can be a little bit slow. Okay, so let's filter down. This should be the only run that has started after 9 a.m. Do we have it? No. Let's look. Actually, let's look back at our logs. What were these names? 110109. Okay, 0921. So it should be showing up here. Maybe not yet. Hit a quick refresh on that one. 11-01-09. There we go. Okay. Sometimes that's a little bit. I'm still working on the like state management in this code. If you want to, if you like, if you're interested in trying this specific code out for your own experiments, like let me know, and I can give you some suggestions on how I've been thinking about improving this. So we at TensorBoard is this experiment monitoring framework. We're serving TensorBoard as part of this hyperparameter sweep demo, this MLOps stack. So you can see we've got all these runs at the start here, and they're getting like various performance because they've got different hyperparameter settings. And then there's this one down here at the bottom in gold. That is the one, it turned out, like at the point that we checked performance, that's the one that's doing best. And so then we actually stop all the previous runs. You can see they only make it 500 steps. And we switch over to the other one and then keep training. Looks like our state loading wasn't perfect there. Probably something missing in our optimizer state dict. So that's definitely something to debug on the ML side. But on the pure like ops side, like the key point here is that we have multiple runs. We pick the one with the best performance and we keep training it. So you can see it right here in our logs. Another fun one. This is something that like looking just at those kinds of charts is like, it's definitely nice. You want to define your problem well enough that you have metrics that are like scalars like that you can trust. At the same time, you're like there's no real substitute for like having the actual like model inputs and outputs to to see how the model is behaving. Actually, there's one other better thing, which is being able to actually play with the model, which we'll see in a second. But it's really important to be able to see inputs and outputs because it's easy for like a low-dimensional projection, like a single number, to fail to capture some surprising new behavior of your system. So TensorBoard actually does support this. So you can, I logged some like text outputs. I think this is in response to the prompt Hamlet : so we can see after about 500 steps, which is the point at which we stop the models, they've gone from what they started at the beginning, which is just gibberish, through like vaguely Shakespearean gibberish to even more Shakespeare-y. Still, they of lorgies of which find the smankin kind of sounds like Shakespeare, or kinds of sounds like Elizabethan English, but there's still some issues. This is, I think, the run that we kept training, because we can see it's gone to a later step. So this is almost 2,000 steps in. You can see there's some names. If you're familiar with Shakespeare, you would know that Buckingham and Henry Bolingbroke are in fact Shakespeare names. Oh, she-daughter Bolingbroke. That's basically Shakespeare. That author, should he wear men your Rome life? Not quite. Still not there yet. But again, this is a small language model. We aren't training it for that long. But we can see the clear improvement of this over even, 500 steps in. A lot of this is more garbage than this output. These kinds of rich logs are really, really important for like monitoring your experiments, for developing your understanding of your model and your problem domain, and it being like confident enough to ship new models into production. Obviously, there's more to build to do that fully, but this is an important building block. But these kinds of like static logs aren't the best thing. The best thing is something interactive. So for folks on the like ML side, let me see, how's our training? I just want to check in on our training. Okay, yeah, looks like our training finished there. Did it finish? 2,000. It sure did. All right. So the training finished. So actually, all that infrastructure we spun up is actually gone. It was an ephemeral application. It was only temporary. So let me just quickly, I'm actually going to set up another ephemeral application rather than continuing to train, set the training to run for longer. I can actually just serve this, and it's actually the same URLs that we got previously, but now with just serve, I'm not running that script. I'm not running the local entry point of the script that trains the models. I'm just setting up all of the web apps and deployed functions and things from that code file from the HP Sweep GPT. So training, monitoring, etc. So let me do a quick refresh, make sure that that's running, and yeah. Oh, looks like you can see there's another training run happening in our in the Modal Labs environment. That's, I think, one of our CI runs, checking that our Dream Booth fine-tuning example is running. Okay, great. So we're able to reload. So what was I talking about before I restarted our server? We were just looking at some outputs. But looking at inputs and outputs is like one thing. Really, what you want to do is maybe you want to try something with the model. So these are fast API, like Swagger docs or Open API docs. So this comes for free with fast API. Let me maybe show you the part of the code where these things are coming up from. So monitor _ training. So this is the part where we were serving TensorBoard. And now let's find web generate, I think the name of it. So this here, this is the code for serving a little fast, a Python function as a fast API endpoint. This is the simplest way to make a web service on Python, something accessible via REST API. It's this modal web endpoint decorator for our function. So this, adding this little docs equals true parameter make sure that you get this nice interactive documentation, Swagger docs style. So now we can send a prompt. It's going to go to that model that we trained, that we kept training, and to its most recent checkpoint. You could definitely make that configurable, but for simplicity, we ended up just going with this. All right, so and now, so we've hit it. I hit it through these interactive docs because I kind of like Swagger docs. They're kind of they remind me of things they've got authentication built in. They help you with remembering what goes in query parameters versus what goes in the body. If you put pedantic schemas on things, then actually these things become really rich and powerful, which is cool. If you're not into that, the core thing that we put out was just a web endpoint that you can that you can hit. So let me just drop back into my terminal and run that. Let's hit this model from the terminal. I got this command from the Swagger docs, which is really nice. They show you how to do that. So it doesn't look super nice in the terminal, but you can at least run it. And the real point that I'm trying to demonstrate there is that you have a web endpoint with this model, and that would also be something that you could hit while the model is mid-training, that you can send in inputs and get outputs. We've got it like deployed as a remote, as like a remote function. So you can, like, from a Python environment, you can look up this like model inference class, or within the same Python file, you can just refer to that class. And then you can call it like as though it were a Python function in your local environment, but it runs in Modal. So we have that. We have a web endpoint that you can hit from outside of Python, or like from something that prefers to like go over the web, even within Python. And then finally, let's see the last little piece here. We were just in the terminal using curl and JQ, like very engineering approach to like testing a model or interacting with a model. But a lot of the people who care about the outputs of an ML team are actually not the engineers. They're like other stakeholders in an organization. They're they're users. They're domain experts. Like if you're working on a chatbot for doctors, then you probably want some doctors to look at your model outputs. And if you know a doctor who can also run terminal commands and is a full stack application developer, then they can use something like this tooling. Maybe they can look at your TensorBoard logs. But that kind of person is pretty rare. So what you want to do instead is you want to hand them a user interface. So this is a simple Gradio interface on top of our models. And we'll be able to like select the model version that we want to run, and then put in input in like a nice, like user-friendly way. We had a little reload there. I want to reload to make sure we're looking at the most recent version. Nice little feature of this UI that isn't incorporated into the command line interface just for reasons of making the code simpler. So you can actually like select the model version that you want to run. Let's pick this most recent model version, the one that we just trained, send in an input. And this is now gonna, basically this is just wrapping the other things we've deployed in this user interface. And so if God wills it, we will see an output. Hamlet, nay, way shall forjast you, a graining in her yalf this hither, no there, sir, no piasm of ham and eel. Beautiful. So yeah, again, the quality of the outputs isn't the point here. The point is the like infrastructure that we've got. So you could hand this off to somebody who is unfamiliar with Python, unfamiliar with the like guts of your system, and give them this UI that they can use to like test the model that's not been fully deployed to production, that's not your like final version. By storing it on Modal's distributed storage, it's like available forever. So many months later, you might be like, wait a second, when did that weird behavior where the model sometimes starts speaking French, like when did that get introduced? You can go back and look at your past training runs and like send in inputs that cause the problem in production now, or cause the problem in evaluation now, and you can try them with like your old models. And that's something like that's very difficult to do with like a fixed eval set. Like you can't anticipate all the ways things are going to go wrong. And so these kinds of like this sort of like interactive evaluation is really, really important for these like for generative models, I would say in particular, like generative models being ones that like produce these very rich outputs that are like open-ended text or images or video. It's hard enough to like build good evals for a model that outputs like a class identity or or like a regression prediction. It's like quite another thing to do that for a model that generates media. Okay, so that's the whole stack that I wanted to show. Covering like all these different components of MLOps in Modal, from like training and hyperparameter sweeps with experiment monitoring, plus like live deployment of models in training, both as APIs and as web user interfaces. I'm not necessarily recommending that you just like, throw out your MLOps stack and immediately use this. As an early employee and shareholder of Weights and Biases, obviously I'd advise you not to do so. But what I'm trying to show here is that with the like fundamental primitives and components that Modal makes available, like distributed storage, web app serving, remote procedure calling, like all of these things are the pieces that you need to build this really cool, like really awesome MLOps stack. So when you need to like customize things, you need to glue together components that you're getting from elsewhere, Modal is going to have what you need. And it's going to power that with infrastructure that doesn't get in your way, that doesn't slow down your iteration and your experimentation, and that like scales up as you need it and only charges you for the actual stuff that you need. It doesn't require you to keep 32 H100s hot all the time just in case. So if you end up trying this out, please let me know. My DMs are open on Twitter, Charles_IRL. If you run into any issues or problems with this or any of the other Modal examples, I'm your guy. You can find me via Twitter or the Modal Slack, modal.com/Slack. You can post questions there, and I or one of the other team members will answer them. We take the quality of these documentation examples very seriously. We try and maintain them as well as we maintain the rest of our code, because we want you to be able to take these and use them as a blueprint for building the things that you actually need to build. Take care.